Here we're going to identify which of these right here is the same as cosine x times tangent x. And the good strategy is we should try to work with just sine and cosine, right? So we have cosine x right here, that means that's good. But for tangent x, we should try to write this as sine x over cosine x. And that's the identity for tangent x, right? So once again, let me just put that down. This is cosine x. And for the tangent x, I'll write that as sine x over cosine x. And we have to remember this really, really well, okay? And next, you see that we have cosine x, but then we have this cosine x in the denominator. Therefore, we can cancel them out, right? At the end, we just have this sine x. And this right here will be the answer for it. And that's choice C. And we are done. That's it. Okay, here we have sine squared x times cosecant x times secant x. And the good old strategy is let's work with sine and cosine only, right? So for the sine squared x, that's good. We'll just write it down as how it is, sine squared x. And then we see that here we have cosecant x. And we have to remember what's an identity for cosecant x. This right here is the same as 1 over sine x. And once again, we have to know these kind of things really, really well, right? And next, we have to multiply the secant x. And for secant x, this is the same as 1 over cosine x, okay? And for all these three things right here, they are all multiplying. And now let's see what we can do with this. For the sine squared x, when the notation is written this way, this means we have sine x times another 1, okay, times another sine x. And I purposely wrote this down like this so that I can show you this sine x can be cancelled with this sine x in the denominator, so we can just cross them out. And altogether, that's what we can do, and we will see that sine x on the top only, times 1 just sine x, right? Over this cosine x on the bottom, so let's just put that down. And what's sine x over cosine x? Well, this is the same as saying we have tangent x. This right here is the simplest that we can get, and that's choice B that we can see right here. And that's it. Okay, here we have tangent x times cotangent x is equal to what, right? All right, so good old strategy. Let's write everything in terms of sine and cosine. For the tangent x, this is the same as saying we have sine x over cosine x, okay? And we'll multiply, so let me put a dot right here. For cotangent x, this is the same as what? Well, for this right here, it's the same as cosine x over sine x, okay? And now what? Well, we can see that sine x, these two can be cancelled. And likewise, cosine x, we can also cancel that. Well, everything got cancelled out. What's the left over? Well, at the end, this is still a 1. Don't forget about that. So at the end, the answer is choice C. It is a 1. That's it. Okay, here we have tangent x times sine x. And we already see that here it is the tangent x. Let's write that as sine x over cosine x right away, right? And then here we have the sine x, so let's just put that down. And now, as we can see, we have the sine x right here. This can be multiplied with the sine x because this is the same as sine x over 1. So we will have sine squared x, and we'll put that on the top like this. And then this is still over that denominator, which is cosine x. And it seems like we did some work already, right? But this is not one of the answer choices right here. So we have to do a few more things right here. As we can see, we have the sine squared x, and there's also an identity for this, sine squared x. And let me tell you guys what it is. This right here, it's the same as 1 minus cosine squared x, right? Because we know sine squared x plus cosine squared x is equal to 1. Therefore, sine squared x is the same as 1 minus cosine squared x. And we have the same denominator still, so this is all over that cosine x, like that. And what can we do next? Well, we have two things on the top, right? Two terms. They are separated by this subtraction. That's why we have the first term and also the second term. And we only have one thing on the bottom, just cosine x. When we have one thing on the bottom, we can split the fraction. So we can look at this as 1 over cosine x. And then minus, this is just the same as cosine square x over that cosine x. Okay? And now let's see what we can do right here. Well, for this one, 1 over cosine x, we know we can write this as secant x, right? That's the definition of secant in this case, right? And for this right here, this is cosine square x over cosine x. You know this is the same as saying cosine x times cosine x, 2 of them on the top. I can cancel this with one of them. So this is minus that cosine x. And that's what we have. Secant x minus cosine x, which is choice C again. And that's it. Okay, this one we have 1 over cosecant x. And if you notice the identity right away, you know this is equal to sine x, right? Because you know cosecant x is the same as 1 over sine x. And 1 over cosecant x will be just sine x. You're done, all right? But I will also show you guys some work for this. Right here, if you would like, you can put down the 1 on top, over, and for the cosecant x part, I will write this down as 1 over sine x. And we have to know this really well. But you see, we end up with a complex fraction, and this is how we are going to take care of this complex fraction. We have the sine x in the denominator for this little fraction. What we can do is, we're just going to multiply sine x on the bottom, and also do the same on the top. And when we do that, you see this and that will cancel. Altogether, 1 times sine x is just sine x over 1, which it doesn't matter. So this is it. And that's choice A. That's it. Okay, here we have tangent x over sine x. And the usual strategy is let's write the tangent x as sine x over cosine x, right? So let's go ahead and do that. For this, this is the same as sine x over cosine x. And don't forget, we still have this big fraction bar. So let's do that. And we still have this sine x on the bottom, right? And once again, we end up with a complex fraction. And the way that we are going to take care of this is that, well, the cosine x, it's a denominator of a small fraction. So I will just multiply the top by the cosine x. And we'll do the same on the bottom as well, like this. And when we do that, you see this and that will cancel. And we will end up just the sine x on the top, right? Over sine x times cosine x. So let's put that down right here. And notice that sine x, they cancel each other out. So at the end, we see this is just 1 on the top over the cosine x on the bottom. And what's 1 over cosine x? This is the same as secant x. This is it. So that's answer choice C right here. That's it. Okay, for this one, we have cotangent x over cosecant x. So once again, we'll write everything in terms of sine x and cosine x, and then we'll see what will happen from there, right? So let's take care of the cotangent x first. What's cotangent x? This is the same as cosine x over sine x, all right? So you have to remember this really, really well. And we have this fraction bar, let's put that down. And we have the cosecant x on the bottom. And let me put this in blue for you guys, for this right here. And what's cosecant x? This right here is the same as 1 over sine x, okay? So we did the fix already. We wrote cotangent x as cosine over sine, and then cosecant as 1 over sine. And this is a complex fraction. And notice that the denominator is sine here, and then this is also the same thing, right? So what we can do is, let's just multiply the top and bottom by the same denominator, which is the sine x. Let's just do that. And you will see this and that cancel, this and that cancel. That's super nice, isn't it? On the top, we will just have cosine x. Over, on the bottom, we just have 1. So this is just cosine x over 1. In another word, just cosine x. That's it. And that's answer choice B right here. For this question, we have tangent square x plus 1 is equal to what? And we technically have 2 ways to do it. The first way is that you will have to remember a lot of identities. In that case, you can just go ahead and say tangent square x plus 1. It's the same as secant square x. However, in this video, I do want to show you guys a more like a traditional way to figure this out. And that is, we will first rewrite the tangent square x in terms of sine square x and cosine square x. So let's do that. For the tangent square x, this is the same as sine square x over cosine square x. And once again, the power, they have to match. All right? And we still have the plus 1 right here. And this is what we have. And now, as you can see, we have this is pretty much like a fraction. Plus 1. And what do we need to do to add fractions? Well, we need to have the same common denominator, right? And first, let me make the 1 as 1 over 1. And as you can see, this is cosine square x. I will have to multiply this 1 by the cosine square x so that the bottoms will be the same, right? And don't forget to do the same thing on the top right here as well. So let's multiply this by cosine square x. And we can continue. As we can see, we are adding fractions, and now the denominators are the same. When we combine the fractions, the denominator will stay the same, cosine square x, okay? And then on the top, we have the sine square x. Let me just put this down right here. And then we are going to add it with 1 times cosine square x is just cosine square x like this, okay? And is there anything that we can do? Well, let's take a look at the top. Sine square x plus cosine square x. Do we notice anything right here? Yes, because this is equal to 1, isn't it? So in another word, on the top we just have a 1, and then the bottom is cosine square x. And now, what's 1 over cosine x? That's secant x, right? But in this case, we have the square, so this is the same as secant square x. And this is what we have, and that's choice B. Okay, and that's it. Okay, here we have cosecant x minus sine x is equal to what? Well, we notice that we have the cosecant x. Let's write that as what? This is the same as 1 over sine x, isn't it? And then we'll continue. We have the minus, and then we have this sine x, isn't it? And now, how can we subtract fractions? Well, let's put down the sine x as sine x over 1, and we have to get the common denominator, isn't it? This is sine x already. This is 1. I have to multiply this 1 by a sine x, so that this will be the same as that. And don't forget to do the same thing on the top as well. So we multiply this sine x by this sine x. And this is what we have at the moment. And now, after we have done that, we see both of them have the same denominator. And when we subtract fractions, we know the denominators will stay the same. So let's put that down as altogether, all over the same denominator, sine x. And then on the top, we have this 1 and then minus. So let's put that down, 1 minus. Sine x times sine x, that's sine square x. And as you can see, this is certainly not one of these. So we have to do more work for this, right? And we see that we have 1 minus sine square x. Do we recognize anything right here? Yes, we should. This right here, it's the same as cosine square x. And once again, we have to know these identities really well. This is the Pythagorean identity. Sine square x plus cosine square x is equal to 1. And this is another version to look at the identity. 1 minus sine square x is equal to cosine square x, right? And then we still have this over sine x. And now, what can we do to get this to become one of these right here? Well, we notice that this is cosine square x, isn't it? This is the same as saying we have cosine x, and then we multiply by another cosine x, isn't it? And now, you look at, we have a cosine x right here over this sine x. What's cosine x over sine x? Cosine x over sine x, it's the same as cotangent x, okay? So the black part right here, this over that is cotangent x. And we still have another cosine x that's multiplying on the top, right? So we just need to multiply this by cosine x. This is it. The final result that we have is cotangent x times cosine x, and that's the answer choice A right here. And that's it. Here we have cosecant squared theta plus secant squared theta is equal to what? Well, first notice that we are using theta in this equation, so be sure you use theta all the way, all right? And also, of course, let's write everything in terms of sine or cosine. For the first one, cosecant, we know that's equal to 1 over sine, but this is cosecant squared theta, which it will be the same as 1 over sine squared theta, okay? And then we will add this with secant squared theta, and for secant squared theta, this is the same as 1 over cosine squared theta, all right? And now as we can see, we're trying to add two fractions. They don't have the same denominators yet. We have to make it happen first, right? This is sine squared theta, this is cosine squared theta. Let me just go ahead and multiply the first fraction, the bottom here, by cosine squared theta, and also do the same on the top. And let me come to a second fraction, and I will multiply this by sine squared theta on the bottom, and also do it on the top. Notice that the denominators now are the same, right? And of course, the order of multiplication doesn't matter. And when we're adding fractions, once the denominators are the same, it will stay the same. And let me just put it down as a big fraction. And we'll write this down as sine squared theta times cosine squared theta for the denominator. On the top, we have 1 times this, which is just going to be cosine squared theta. And then we are adding with 1 times that, which is just that. So we plus sine squared theta, okay? And now, do we recognize the top? This is cosine squared theta plus sine squared theta. In another word, sine squared theta plus cosine squared theta. In another word, this is just equal to 1, right? This is the Pythagorean identity. And that's pretty much all we have on the top. And of course, the order of addition doesn't matter. So altogether, you add this and that is 1. So we have a 1 on the top over that denominator, sine squared theta times cosine squared theta, all right? And now, this is unfortunately not the same as one of these yet, right? We have to make it happen. So notice that on the bottom, we have sine squared theta times cosine squared theta. I can also split the fraction because this is multiplication. I can do it this way for you guys. This is the same as saying 1 is still 1 on the top over sine squared theta. And we multiply by the second one, which is, I can also write down 1 for you guys, over this, which is cosine squared theta, right? And the reason I can do that is because, remember, when you multiply fractions, you can just do top times top. 1 times 1 will give you this 1. And then you put on over bottom times bottom. Sine squared theta times cosine squared theta is this one. So you can still kind of separate the fraction like this, all right? All right, the point for me to do that is because now we will see 1 over sine squared theta. This is just cosecant squared theta, isn't it? And we are multiplying, right? The middle is just a multiplication. Here we have 1 over cosine squared theta, which is the same as secant squared theta. So if you notice, this is the tricky part, or maybe the fun part. Originally, this was addition, but in fact, it's the same as a multiplication. Cosecant squared theta plus secant squared theta, it's the same as cosecant squared theta times secant squared theta. All right? So indeed, they are equal, and this is choice A right here. That's it. Let's look at this one. We have cosine squared t minus sine squared t is equal to which of this right here? Notice that both of these terms, they are in terms of sine and cosine already, so I don't need to do the usual step, right? But I still have to identify this is equal to which of this. And it seems to us that we have a difference of 2 squares. Maybe we can factor it, but if we factor it, we will end up cosine t minus sine t in the first parentheses, and then times cosine t plus sine t in the second parentheses. And that is not one of this right here, neither. So in this case, what can we do? Well, let's notice that this is not just a cosine t, this is a cosine square t. And for cosine square t, we do have an identity for this, right? This is the same as 1 minus sine square t. And let me just use this right here to replace cosine square t, right? And in fact, yes, there's also an identity for sine square t. That's the same as 1 minus cosine square t, right? But let me replace this right here with cosine square t. That's how you do it for this equation. And we will just continue. We will just put down the minus sine square t. And the reason that I want to keep the sine square t right here is because you see that this is minus sine square t, and then we minus the same term again, minus sine square t. This is minus 1, and this is also minus 1. So altogether is minus 2 of them. Therefore, this is the same as saying 1 still all the way in the front, and then minus 2, and then sine square t, right? So we kept this right here so we can combine like terms. And when you replace the cosine square t with this right here, and once again, this is the Pythagorean identity, another form, right? We combine the like term right here, and we end up with 1 minus 2 times sine square t, and this is answer choice B right here, and that's it. For this question, we have 1 minus sine x and then times 1 plus sine x, right? We have two ways to do this. The first way is you can use a formula to multiply this out, and that's the difference of squares formula. But I will show you guys the other way, which is you can just go ahead and follow this out, right? To convince you guys that the formula is correct. Anyways, I will just go ahead and do 1 times 1, which is going to be 1. And then 1 times sine x is going to be plus sine x, right? And then we'll continue. We'll take this times that. This is negative sine x times 1. So that's negative sine x. And then negative sine x times positive sine x, it will be minus sine square x. And as you can see, this and that cancel out. Sine x minus sine x, just 0. So in another word, we all have 1 minus sine square x. That's all we have, right? And this is not one of the answer choices, but we know 1 minus sine square x is the same as cosine square x. As I said, this is the identity that we have to remember really, really well. And this is answer choice A. And that's it. Let's talk about this one. We have cosine x over 1 minus sine x. However, before I show you guys the right way to do this, let me show you guys a common mistake. So this is just going to be incorrect, right? This is a wrong way to do it. Well, if you look at this right here, yes, we do have a cosine x on the top. And we have two things on the bottom, namely the 1, and then we subtract the second one is the sine x, right? If you just go ahead and put down cosine x and then over this 1, and then you put down the minus in between, and then you still put down the cosine x right here, and then over the sine x right here. And if you do it this way, you will end up with cosine x over 1, which is just cosine x, and then the minus still minus, and cosine over sine, we know that's cotangent, and we have the x as the input. Well, this is incorrect. And the reason is because when we have two terms on the bottom, we cannot split the fraction like the following, okay? So do not do it like this. And with this being said, you see that choice B is the wrong answer, right? This is a wrong answer for it. So let's get rid of that. And now, of course, I will have to show you guys the right way. But as we can see, this expression here is in terms of sine and cosine already. So in that case, what can we do though? Well, look at this is 1 minus sine to the first power x. This looks similar to one of the things that we know. And let me put that down for you guys. This is what we know, all right? We know that when we have 1 and then minus sine to the second power x, this right here, we do have a nice identity for this. This is the same as cosine square x, isn't it? As you can see, this is just sine to the first power, but this is sine to the second power. But if you look at this right here, 1 minus sine square x. If you would like, this is the same as 1 square minus sine square x. This is technically a difference of 2 squares. Namely, we can factor this out. If we do that, you will end up with, this is 1 minus sine x, and then we times by 1 plus sine x when you factor out the difference of 2 squares. Well, if you come back here again, we have the 1 minus sine x already, which is this. If I multiply this bottom by 1 plus sine x, well, we can produce 1 minus sine square x, and in that case, we can produce cosine square x, and we can go from there, right? So let me write this down again. Cosine x on the top over 1 minus sine x, and what we'll do is we multiply the bottom by 1 plus sine x, and this right here is called the conjugate of that. So this was a minus, we just change this to plus, right? And you can imagine, if this was a plus, we will change this to a minus. Anyways, right here, I'll just multiply the bottom by this and also do the same on the top. 1 plus sine x, like that. I will continue from here. Well, this times that, it's exactly 1 minus sine square x, and we can put that down right here, depending on how much work that you would show right here, all right? If you would like to show all the steps again, you can say this is equal to, let me just write this down. This is 1 minus sine square x, which is the same as just cosine square x. But we did that right here already. Anyways, right here on the bottom, we just have the cosine square x. And for the top, I am not going to distribute the cosine x into the parentheses because I have the cosine square on the bottom already. Let me just keep it as how it is. This is cosine x times 1 plus sine x. And the reason for me to keep it this way is because, remember, this means what? This means cosine x times cosine x. We can cancel out this cosine x with one of the cosine x on the bottom, right? So in another word, we will just have 1 plus sine x on the top all over cosine x, like this. Well, we did a lot of work already. We go back to the answer choices, and you see that this right here is exactly the same as answer choice A. So we can be done right here already. So this right here will be the answer, right? That's it. However, I do want to make one last remark. It's possible for us to continue, but we stopped it right here because this was in choice A already, right? So if you want to continue, just in case if this wasn't one of the answer choices, what we can do right here is that we only have one term on the bottom. We have 2 terms on the top. In this case, we can split the fraction. So this is the same as 1 over cosine x, and then plus, and then we have the sine x over this denominator cosine x. This right here is correct, okay? This is okay for us to do. Earlier, when we have 2 terms on the bottom, we cannot split the fraction. But this right here was okay. If you continue, you see this is secant x, and we add it with sine x over cosine x. This is tangent x. But this is not one of the answer choices. Choice C, right here, this is secant x times tangent x. This is so different than this one, right? So the deal is, whenever you're doing these kind of things right here, as long as you can see one of the answer choices is what you have, you can stop and that will be the answer. If not, you may possibly have to do more work, such as this. But this is not one of the answer choices, so this is not the answer. It could have been the answer if this right here was maybe C, but that's a plus. But I cannot give you 2 answers in one question, right? So anyways, this is it. Now we have 1 over tangent x plus 1. Well, because we have the tangent x, we can just go ahead and use the Google strategy, right? Let's rewrite tangent x as sine x over cosine x. So let's do that. 1 over, this is sine x over cosine x, and then we still have the plus 1 after that. And as you can see, this is a complex fraction. It's more intimidating, but we still do it with the same principle. That means I will just go ahead and you see the denominator of the small fraction is cosine x, right? I will multiply the entire bottom right here by that cosine x. And we do the same on the top, of course. And let's see, what do we have? On the top, 1 times cosine x is of course just cosine x. And we have this over, and I will put this down in red. We distribute cosine x with this, right? When you do cosine x times this cosine x and that cosine x will cancel out when you distribute. That means you will have the sine x left. And then you distribute the cosine x with the 1. So this is plus 1 times cosine x, which is just cosine x. At the end, we see that we have cosine x over sine x plus cosine x, and that's answer choice C. So we know we are done. This right here will be the answer, and that's it. Okay, for this one, we have secant theta over cosine theta, and then minus 1 is equal to what, right? Well, we have secant theta, so let's write the secant theta in terms of sine or cosine. This is the same as 1 over cosine theta. That's all, right? For secant theta. And then we still have this over this cosine theta, and then we still have the minus 1 after this, right? And now, this is a complex fraction, so let's go ahead and fix that. So to do so, I'm going to just multiply the top and bottom by this cosine theta, so that this and that will cancel, and that's very nice. And then we will have just a 1 on the top right here, right? So we have 1 over, and this is cosine theta times cosine theta, namely cosine square theta. And then we still have the minus 1 right here. And now we have to subtract fraction in this, right? So let's put on the 1 as 1 over 1. And let's multiply this by cosine square theta on the bottom here, and do the same on the top. And when we do that, this and that are the same. So we can just say this is going to be all over cosine square theta. And on the top, we just have this 1, and then minus 1 times cosine theta, cosine square theta. This is just that, right? And can we do anything else? Well, notice 1 minus cosine square theta. It has an identity for that. This is equal to sine square theta, and then over cosine square theta. At the end, what's this? Well, we know sine over cosine is tangent, but this is sine square over cosine square. Namely, we will have tangent square, and the input is theta. So this is what we have, and that's answer choice C right here. That's it. Right here, we're going to add cotangent x plus tangent x. And of course, the first step should be rewrite everything in terms of sine x and cosine x. Okay, for the first one, cotangent x, this is the same as cosine x over sine x. Okay, and then we'll be adding this with the tangent x is the same as sine x over cosine x. And once again, we must know these kind of things really, really well, okay? And then from here, we're just going to add the fractions. And be sure we get a common denominator first. We have sine x here, we have cosine x here. So that means right here, I shall multiply the bottom by cosine x, and we do the same on the top. And right here, I have to multiply by this sine x, right? So let's do that. Sine x here and sine x here. Okay. After we've done that, the denominators are the same. I will just combine them, and it will stay the same for the denominator. I'll put on sine x times cosine x like this. And then on the top, this is cosine x times cosine x, namely cosine square x. And then we will be adding with sine x times sine x, that's sine square x. And that's what we have. And what's next? Well, look at this right here. This is cosine square x plus sine square x, which is the same as sine square x plus cosine square x, which is the same as just a 1, right? So this is equal to 1 on the top. Let me just put down the 1 right here. And then over sine x times cosine x on the bottom like this. Well, you see, this is not one of this yet, right? And here, we can still break this apart because this is sine x times cosine x. We are going to do it this way. This, it's the same as saying 1 over sine x. Let me put that down right here for you guys first. And we can say this is multiplying with another 1 over cosine x. And the reason is because, remember, when we multiply the fractions, we just do top times top. And you see, 1 times 1 is this 1, right? And then we divide it by, we just put on over, the bottom times bottom. Sine x times cosine x, we get that. So whenever you are having this kind of situation, you can kind of just look at this and that like this with a multiplication. Anyways, right here, for the first part, we have 1 over sine x, and this is the same as saying cosecant x. And we will multiply this with 1 over cosine x, which is the same as secant x. And this right here will be the result. And this right here is answer choice A that we have right here. And that's it. For this question, we have 1 minus sine squared x over 1 minus sine x, and then minus 1 is equal to which of this right here, right? Well, yes, I noticed that on the top, 1 minus sine squared x, this is the same as cosine squared x. But I'm not going to do that because it wouldn't do us any good, right? I cannot simplify anything if I replace the top with cosine squared x. Because I noticed that on the bottom, we do have 1 minus sine x, right? On the top right here, let me just go ahead and factor this out. And if I do that, I will get 1 minus sine x and then multiply by 1 plus sine x, right? This is the difference of two squares, and we can factor it out like that. And right away, we see this and that, they are the same factor, so we can cancel them out right away. So in other words, this part is just 1 plus sine x, all right, for the fraction, and then we have the minus 1. What's this? Well, this and that will cancel, right? The 1 and then the minus 1, they pretty much just cancel each other out, so we just end up with sine x. That's all. And this is the simplest that you can get, of course, right? Answer choice C, just like this. Here we have sine to the fourth power x minus cosine to the fourth power x. Well, yes, both terms are in terms of sine and cosine already, so there's nothing that we need to do for that, right? But what can we do to get this to be the same as one of these right here, right? Well, we have a difference of two terms. So I suspect that we may be able to factor this out. And also because we're the fourth power, yes, I can just go ahead and use the difference of two squares formula to factor it out, right? But before I do that, I have to set it up first. So to do so, let me show you. For the sine to the fourth power x, I will have to write this as sine square x and then square like this, right? You see, we can multiply the powers and we can get a 4 back right here. And the reason I have to do this is because I need to look at this as a square and then minus b square. So I can use the difference of two squares formula to factor it out. All right, I'll continue. I will say this is minus, and as I said, I'll put on parentheses something square. And for this parentheses inside, I will have to rewrite this as cosine square x. And then when I take this, square that, I get that back. All right, so we can continue. A square minus b square, this is the a, this is the b. We know the formula will be a minus b times a plus b, right? So that's the formula to factor that out. Let's write that down. Sine square x for the a, and then we minus the b, which is that, cosine square x. And then we have the second part, a plus b. A is sine square x, so let's put that down right here. And then we add it with the b, which is cosine square x, right? So right here, cosine square x. So we factor this out, but what can we do next? Do we have any identity for sine square x minus cosine square x? Well, not as I know of at the moment, right? How about this? Sine square x plus cosine square x. Yes, we do have a really nice identity, isn't it? This is just equal to 1. In another word, we just have this quantity times 1, which is still just this quantity, isn't it? So at the end of the day, this is just the same as sine square x minus cosine square x. And you see the crazy thing is, yes, earlier we start with the fourth power minus the fourth power. And in fact, in this situation, it's the same as the square minus the square, right? It's just because this works out like that. And the answer will be choice A, sine square x minus cosine square x, and that's what we have at the moment. That's it. For this one, we have secant x minus cosine x, and then all over tangent square x. And yes, we only have one term on the bottom, but I don't want to split the fraction yet, because I want to rewrite everything in terms of sine and cosine first, and it will end up to be a complex fraction. I want to take care of the complex fraction altogether first, all right? So with that being said, let's see. This is secant x, which is the same as 1 over cosine x, right? And then minus, this is cosine x, so let me just keep it as how it is. And then all over, for the tangent square x in the denominator, this is the same as sine square x over cosine square x, right? And now we'll take care of the complex fractions altogether. So we see that this is the small fraction, this is another small fraction. The denominator here is cosine x. The denominator here is cosine square x. I'm going to multiply everything by cosine square x. You pick the bigger power, right? So let me do that. Let me put this down in red. Let's multiply the top by cosine square x, and we do the same on the bottom as well. And you see, this is what we need, because on the bottom, this and that cancel out right away, isn't it? So you just have sine square on the bottom, x like that. And when you distribute this and that, cosine square x times 1 over cosine x. Remember, this means cosine x times cosine x. You can cancel one of them with the bottom here. So 1 over cosine x times cosine square x is just going to be cosine x, and this is only to the first power right here, right? And when we do this times that, this is a minus cosine x times cosine square. Well, this is the first power, this is the second power. When we multiply, it becomes the third power, right? So we have cosine to the third power x, like that. So this is what we have at the moment. And what can we do next? Well, on the top, we have cosine x minus cosine to the third power x. I can factor out a cosine, right? So let's do that. I want to factor out a cosine x, and then in that case, I will just left with 1 right here, because this was cosine to the first power, but I factored it out earlier. And then, originally you have 3 powers right here, right? The third power here, I factor out one of them, so it becomes just minus cosine square x, like that. And I still have this over sine square x, okay? And the reason I want to factor this out is because this part, 1 minus cosine square x, we know what this is, right? This is the same as sine square x. So let me write this down for you guys nicely. This is cosine x, and this right here is sine square x. And we have this all over this sine square x on the bottom. And guess what we can do? Of course, cancel, cancel. Very nice, right? So at the end, altogether, that is equal to just nothing but cosine x. That's what we have. And that's answer choice A right here. And that's it. Here we're going to subtract 2 fractions. The first one is 3 over 1 minus sine x, and then we'll minus the second fraction, which is 3 over 1 plus sine x. And what's the most important thing that we need so we can subtract fractions? Well, we have to make sure that the denominators are the same, right? This and that look similar, but still they're different. Be sure you multiply the first fraction right here, the top and bottom, by 1 plus sine x, right? And then for the second fraction, you multiply the top and bottom by 1 minus sine x. So you can produce the same denominator. and they happen to be the conjugate of each other, but it's okay. We are trying to get the common denominator first. All right, so let's get to work. Let me put this down again. 3 over 1 minus sine x, and I'll multiply this by 1 plus sine x, and do the same on the top, of course. And then we will minus 3 over this, right? 1 plus sine x, and I will of course take this and multiply by that, so which is the 1 minus sine x. And you will see right now that this and that are the same, so you produced the same denominator, right? Okay, when we have the same denominators, when we are subtracting, you know the denominators stays the same. And this right here, you can multiply out real quick. 1 minus sine x times 1 plus sine x, you know this is going to be 1 minus sine square x. And if you like, you can go ahead and put this down as cosine square x. Right here, you get the same thing, which is cosine square x as well. So let me just go ahead and put down a big fraction bar, and then for the bottom, let me just put down cosine square x right here, okay? The denominator stays the same. And next, we will have to just look at this. This is 3 times 1 plus sine x. Of course, distribute the usual business, right? So let's do 3 times 1, which is 3. 3 times sine x, and that's plus, so that's plus 3 sine x. And next, be careful with the following term right here. We have to take negative 3 times 1. Be sure it's negative 3 times 1, which will end up negative 3. And next, we take negative 3 times negative sine x. Negative times negative becomes plus, right? Negative 3 times negative sine x becomes plus 3 sine x. And this is what we have now, and we'll continue. Well, as we can see, 3 and negative 3, these two just cancel out, become 0, right? And we can combine the terms, because this is positive 3x, and then we plus another 3x, right? Plus another 3 sine x. 3 sine x plus 3 sine x altogether is going to give us 6 sine x. And this is over cosine square x. Okay, we did a lot of work already. But this is not one of the answer choices. And I can get rid of the 3 like this right here, because this is a 3. It's not 6, maybe, right? So what can we do? Well, look at this right here. This is cosine square x, which is the same as saying cosine x times another cosine x, isn't it? And we can break down the fraction as follows. Well, we have the 6 all the way in the front. And check this out. Sine x over cosine x is what? Sine over cosine is tangent. So these two terms in black, we can write it as tangent x. Okay? Sine x over cosine x is tangent x. And for this one, this is cosine x on the bottom. And if you would like, I can write this as multiplied by 1. And look at 1 over cosine x, which is the same as secant x. That's it. Altogether, we have 6 tangent x times secant x, and that's answer choice B right here. 6 tangent x, 6 tangent x, and secant x. And that's it.